So, hi everyone. It's so awesome to be here, and in this experience of a theater of a movie, I feel like I'm in a movie. This talk will be about Terraform practices, the good, the bad, and the ugly. And I'm going to cover not only specific bits and pieces regarding the Terraform usage, but also, hopefully, will make you think about Terraform in a broader context rather than just an infrastructure as code tool. So first of all, hi. My name is Hila Fish. I'm a senior DevOps engineer, as Karen said. I work for Wix. I have 15 years of experience in the tech industry. I have recently joined the AWS Community Builders program, which is an awesome program. You can talk to me afterwards if you like to. I help co-organize conferences in Israel, where I live, DevOps Days Tel Aviv, and Statcraft Monitoring Conference. This is a bit small, so I'm going to... OK. I'm a mentor in... It's about me. I should know about it, right? But anyway, so I'm a mentor at courses and communities in Israel. I'm a DevOps culture fan. I think this is what helps companies achieve great things. And I'm a lead singer in a cover band. As you can see in this picture, it is a lot of fun. OK, so Terraform implementations can be good, bad, and sometimes also ugly. A little bit of a disclaimer. I'm going to show here mostly examples from AWS usage provider, but of course, Terraform works with any providers, so you can apply that to any cloud provider that you work with. And I only worked with Terraform open source, so I will refer to Workspaces, but it is open source Workspaces and not Terraform Cloud, so just bear that in mind. OK, quick wins. When I think about or talk about quick wins, I mean things that you can do and achieve in a matter of minutes that will help you in the long run when you work with Terraform. So first of all, versions lock. The same as you have for requirements txt, packages JSON lock, right? Also, Terraform has a version and with specific syntax and features. So you should really lock the versions in the modules, provider, and Terraform version itself. These are examples how to do it. And the thing about locking the providers module is, as you can see from this meme by Anton Babenko, who is like a celeb in the Terraform realm, there could be always issues with providers. So better lock the version and deal with the devil that you know. So in regards to versions lock, the good thing is to lock modules, providers, and Terraform version. The bad thing is to lock, but in a way that will still allow breaking changes to occur, because if you lock to a minor version as opposed to major version, then still breaking changes will go through, so it's not that great. And the ugly thing is to have no versions lock whatsoever, because trust me, you will have syntax issues, you will have a lot of things that you didn't plan to encounter. Next up is tagging resources. So if you don't know, a lot of usages or cost management that we do in the cloud is done with tagging resources. It is also good to have like a logical arrangement. With the tagging, we know exactly which resources belong to which projects and stuff like that. So it's also good to, always good to tag the resources that you use. And trust me, in regards to cost management, your FinOps team will really appreciate if you do that. And if you don't have FinOps team, then congratulations, you are the FinOps team. So please try to really tag everything that you can. And these are only examples of the tags that we use in Wix. And as you can see, Terraform also has default tags. So if you use default tags, it means that every tag that you that will create through this provider will automatically get this tag. So we use it for managed by Terraform to make sure that all these resources are accounted for in regards to Terraform. And that way, you just do it and forget about it altogether. So the good thing is to tag everything that you can. Use default tags, because then you just set it once and forget about it. And I'm going to cover it in a bit. PR enforcement, if someone added resources in a PR but didn't tag them, then the PR will fail. And I'm going to cover it in a bit. The bad thing is to tag inconsistently, because as we know, consistency is key. And the ugly thing is to have no tagging whatsoever. You can't track anything with that. You will have a lot of issues, especially when you're scaling up, so try to avoid that. And the last in the quick section wins, remote state. So by default, Terraform works with local state. So if you set up remote state, then you can work with other teams. You have redundancy. You have the state being secured, backed up, and stuff like that. So the good thing to have it secured, backed up, remote, and you should also consider do a Terraform state lock. You can use DynamoDB for that to make sure that when people run Terraform apply, then you don't have any conflicts because the states get locked whenever apply occurs. The bad and the ugly are pretty much the opposite, so I'm not going to really cover it, just the opposite. OK, so the next section I want to cover here is second nature. When I say second nature, I mean things that you should think about in your day-to-day that should be your second nature when you work with Terraform. So first of all, community models versus custom models. So community models are the ones that are created by the community. And the thing by using these models is that they are proven over time and really they are supported, of course, by the community, and someone else is maintaining them, so you don't need to maintain them yourself. And the fact is that a lot of well-known cloud provider resources are already managed by community models, so you might as well just use them if the use case fits. So use verified community models. It's very important to use verified because there are a lot of times where community models are not verified, and then it could introduce some security issues or like backdoors that you don't know about. And the bad thing is if you still create models yourself but still maintain them as such, you have practices enforcement and all sorts of things, then it's still OK. And to have a community model without a version lock, as I explained before, it's not that great. And the ugly thing here is to have both a custom model that you create but don't maintain it, because that way you really can't scale and your model could easily become obsolete. And to have use an unverified community model, because then, again, malicious configuration could come and it could get ugly. And if you do have to create your own models, so make sure you make them stateless and clean and generic as much as possible, and have practices enforcement in place. I know I'm doing a build-up towards that, but trust me, it's worth it. So the next thing in the section of second nature is variables versus locals. So variables are pretty much straightforward, right? They're just, you set them up and that's that. And locals are much more complex. You can put conditionals in them. You can merge and use any Terraform functions for doing stuff with the variables themselves. This is only an example of how you set up a project and environment once, and then you use it throughout locals to have that as tags along with other specific resource tags. So this is good. And the thing about locals is the values don't change between runs. So Terraform apply, plan, destroy, local values stays the same. So it's good and to use them both. And let's see when to do it, I mean, in my experience. So on the model side, in regards to variables, the purpose of using variables are to have settings for the model configuration and make sure you set up default or validation, because if not, when someone uses this model, it will just get break, and it's not nice. On, again, model side, but locals, it should be used as a constant to be honored. So for example, if I create an S3 bucket model, and then I want everyone that uses this model to have a naming convention for that bucket, I can set it up as locals, and then everyone that uses this model is bound to have this bucket name convention, and it's good because we all want to have consistency and naming convention, and that's great. So that's that. And on the live side, and when I say live, I mean where we call the models, right? Because models are like classes, right? And you need to instantiate them. So live side is where you call the models. So variables, when you use them once, you can just put default, and that's that. But when you use them multiple times or for regions and stuff like that, then you should use tfvars file that allows you this flexibility. Locals on the live side, so you should really avoid using locals because we aim to keep the live side as simple as possible. So try to avoid that, of course, as much as possible if the use case needs that. So that's OK. And use the data sources to pass their values to the model, because data sources allows you to get values dynamically from the environment. So dynamic we all like, right? So use that. So to sum this section up, use TF vars whenever necessary. You can use also environment variables, so that way you can avoid using creating new variables, because you have like a built-in variables that you can already use. Locals, use them to de-hard code names and decrease code repeatability in general, and try to keep things in generic, because people need to maintain this code and you don't want to over-complex things. The bad thing is to use multiple local blocks if not necessary, because Terraform allows that, to have multiple blocks, but it just burdens your eyes when you have multiple blocks and you don't really need that. So just do it for the sake of readability. Decentralize vars, because you can use a variable TF file and that's that, but you can also spread them out, so just put them in one file, again, for the sake of readability, and ignoring environment variables. And the ugly thing is, of course, to hard-coded values of variables if not necessary, because this is the meaning of variables, to vary. So yeah. OK, next thing. I know I'm covering a lot of things, but I'm trying to speak a little bit slowly. I don't know if I'm able to do it or not, but let's see. So file structure. As we know, Terraform just executes every file in the folder that has the suffix of TF. But again, for the sake of logical arrangement and readability of our code, we need to structure the files in a way that will help us maintain it in the long run. So we can also derive the inspiration from the community standard. So this is how community models are aligning the files. So main TF holds the main logic of the model, and then variables, data, and outputs. So the thing about that is that, let's take, for example, if I have a model to create a VM, I will put the necessary resources to create a VM in the main TF, but if I have peripheral stuff, like creation of security groups or a load balancer, then we should put them in separate files. Again, readability is awesome. And if you manage to create a complex module, you should really think about or consider separating them to submodules, because that way it will be much easier to maintain, and you can also reuse parts of that. So also from community examples, the VPC module has a submodule of VPC endpoint, and the EKS module has a submodule of the creation of the node pools. OK, so this part I like, and I think that you like it as well. Applying classic code best practices on Terraform. So, OK, I thought I would see much more confused faces here. I'm not saying that Terraform is a regular or pure programming language. OK, I think that we all know that. I'm not, all good. Programming languages has their own place. But even HashiCorp, the company that created Terraform, realized that they need to apply classic code best practices on Terraform. And why? And how do I know that? Because before Terraform 0.13, you couldn't even loop over models, and you had to just duplicate the code. As opposed to that, after the release of after Terraform 0.13, you can just call with a single call to the model. You can call it several times. So because of that, we should really apply other classic code best practices on Terraform as well, which means keep the Terraform code in source control management, keep the code as simple as possible, do not repeat yourself if you don't have to. Even functional programming concepts can be applied on Terraform, and the code, of course, should be idempotent. And in regards to human and clean, I want to share with you something that I read in an article by T-Sin Guo. He said, and I totally agree, that code is, computer will just execute the code if the syntax is right? If the computer doesn't care if the variables are ambiguous or not clear, it will execute anyway if the code syntax is OK. But for us, sake of human beings, we need to make sure the code is readable and we can maintain it in the long run and not curse the other person that left the company and that we need to maintain his code, right? So that's why, and basically that's the main reason why we apply these best practices, because for us, the sake of us human beings, to be able to maintain the code better. So please do it. Please, I mean, in your day-to-day, you will experience how good it is. OK, the last section that I want to cover here is the long haul. Long haul, it means that things that you should plan ahead. So if second nature was things on your day-to-day that you need to think about and have as your second nature, long haul is the things that you need to plan ahead before you actually use Terraform or do like substantial things with it. So to answer that, I want to share with you this question. So how do we envision the infrastructure and the company needs? And I want to tell you a story about that. Not long ago, in my daily sync with my team, I'm in the data engineering group, and there's Presto, which is a tool for querying data, and it runs currently on a VM cluster. Good. And then an issue came that maybe we should migrate to Kubernetes, the Presto application, migrate to Kubernetes. And all my team members were like, yeah, let's migrate to Kubernetes. Yeah, it's good, it's awesome, it's And I said to in my heart, I felt, yeah, I want to migrate to Kubernetes. Why? Because Kubernetes is very much adapted, right? And a lot of companies use it. And if I will use it more, because I used it before, but there's nothing, there's no much, too much when it comes to Kubernetes because it's too complex. So if I will use it again, that's good for me, right? Because I will have more experience, I will be better, and then I will have much more experience to showcase for the next employer. But at this point in time, I don't care about me. I care about the application. And at this point, I told all my team members, I said, wait, before you jump the gun, let's read if Presto could even run on Kubernetes, if it's a best practice, if they have an actual use cases that ran Presto on Kubernetes before we get excited and even start the POC. So that's why we really need to think ahead, and maybe Terraform is not the tool for you, or maybe you have a certain usages or certain structure that requires you to do things in a certain way, and that's why that's the first thing I want to share with you. So structuring your Terraform codebase. There are a lot of ways to structure a Terraform codebase, and I want to show you how we structure the codebase in Wix, where I work. So this is how we structure it. We have team, project, cloud provider, and region. And this is an example. So we have, of course, the live and the modules, and then BI for team, Airflow for project, AWS for cloud provider, and US East 1 for region. And the thing about this structure and why we chosen this structure, two main reasons. First of all, we wanted to enable Terraform as the platform. In my company, which is, we have a lot of people, a lot of technical people, we all use Terraform, and we all use it in the same repository, and it is very aligned, and we have practices enforcement, which I will cover in a bit. So it's very easy to onboard anyone that wants to create infrastructure with this structure, because that way, everyone can use it, and everyone can also manage their own code, because as you can see, the top level is team, so they have their own permissions to be approvers on the code with the code owners in GitHub. So that's great, and that way we can really scale as much as we can because of that structure. Another reason why we chose this structure is to have small state files. So the thing with Terraform is that it has, it creates dependency trees, and sometimes it doesn't create a valid dependency tree. So it means that if your state file will be huge, then when you do a change of a tag, okay, you just change a tag, you just change some resource, then in the plan you will see, I'm going to destroy this and this and that. I'm like, no, I didn't ask you to do that. So this is what happens when you have big state files. So that structure will allow you to have small state files, because as you can see, the state file is only for Airflow in BI, in US East 1, in AWS. That's it. So we should really allow or help Terraform do good and avoid invalid dependencies, and that's why this is good to do. Let's cover a bit Workspaces. So Workspaces is an logical isolation. So if you have the same Terraform config, you can just you don't need to duplicate the code. You just have new Workspaces, and then that's it. You just run it, switch context, and that's that. So when you have same Terraform config for example, different customers, like if I have different GCP clients, and each project is a customer, then I can just use Workspace for that. And another example is pretty much coupled with the last one. All customers need to use the same service in that region, right? Like financial service or login service and stuff like that. And we have different customers in different regions. So all these services, like the multi-tenant projects, could be managed by Workspaces, and that's that. So some notes about Workspaces: you should really consider using Terraform wrapper, because how do you use Workspaces? With the CLI, Terraform Workspace select X. If I forgot to do this select, production incident. So try to avoid that. When using Workspaces, you have less visibility, because again, even if you didn't use the Terraform Workspace variable, the built-in variable, you don't even know that you have Workspaces. And even though you can do Terraform Workspace list, see a list of Workspaces, but it doesn't mean that they are in use. Maybe someone created them and forgot to delete them. So you should really think about it when you work with Terraform, and when you think about whether to use Workspaces or not. How much time do I, because I'm not sure I have time for that. OK, I'll cover it in a bit. Just from the documentation, it says basically that these usages are OK, like for multiple environments and multiple regions, stuff like that. But also from the documentation, they said that for multiple deployments of the same infrastructure, serving different development stages, staging versus production, like the example showed that it is good to use Workspaces for, then named Workspaces are not a suitable isolation mechanism for this scenario. So I don't know if they actually meant same infrastructure to serve dev and production. I never did it in my entire career, but if that's the case, or if not, it still made me think, and if that made me think, then maybe it will raise some questions for you. You should just think about Workspaces before you dive right in. And at least we can think about one useful and classic usage for Workspaces, like a side branch. So you can create a new workspace, test out your code, apply, see it all looks good and behaves correctly, and then just apply it back on the default workspace. OK, so the good thing is to really, when you plan ahead, OK, and when you think about what to do with your Terraform structure, codebase, then it will allow you to set up small state files and to run Terraform as a platform, which is very, very important, especially when you want to scale up your company and your infrastructure. The bad thing is that if there are organizational changes that will occur, it will maybe require you to restructure the code, and then you don't want that. You want to structure the code when you have control over things and not when you get sprung by surprise. And of course, bad thing also to use Workspaces for the wrong reasons, as I just showed you. And the ugly, really, it could be really, really ugly if you set up, you don't plan ahead and you set up the structure of the code base to allow huge state files. Then huge state files just means invalid dependencies, and it's not good. Terraform execution, I'm not going to cover it too much because I don't have time. Remote execution for the win. Apply with a plan file and set up Terraform timeout, because if not, then you will maybe forced to do like execute. You will have run and then maybe do Control-C. And trust me, you don't want to do Control-C. Don't do Control-C when you run Terraform apply. I did it when I just started out with Terraform, and it messed up my state. I don't know if they fixed it by now or not, but I don't want to find out. So try to avoid Control-C when you run Terraform apply, and try to also just do remote execution, and all these things will get avoided by design. And practice enforcement, I don't have much time. OK, so it means that basically any guidelines that you want to set up, like tags, if someone added tags or not, or any other guidelines you want to notify someone when someone adds a resource at more than $20,000, right? Any guidelines that you want can be set with practices enforcement. This is an example from the community model, the AWS auto-scaling one. As you can see, he added checks to check if the contributor formatted the code, added documentation, and wrote a working code with TF-lint. So this is only an example, but you can really, the sky's the limit. You can set up any guidelines that you want that are suitable for your use cases and your needs. So you can do pre-merged linters, formatters, and logical checks. You can do it with either GitHub actions or with CI pipeline checks. You can also do create like a Slack bot to detect drift reports. But if you do like a setup like we did in Wix, in which we have PRs and we have Atlantis runs the PR, then when I run Atlantis apply, the PR gets both merged and applied. And that guarantees that the main is the actual environment, which is always good, because then you avoid drifts, and that's that. The bad and the ugly are in regards to if you don't use practice enforcement, then you could face security issues and non-compliant configuration, which we always want to avoid. And on the right, I've put some open source enforcement and helpers to help you in your journey of integrating practice enforcement. So that's that. OK, so I'm almost finished. So we had a question, right? How do we envision the infrastructure and the company's needs? And then I talked about some stuff, about the structure, about scaling and stuff like that. And I hope that during my talk, some stuff raised in your head about your usages and your use cases, and you can say to yourself, yeah, this is how we envision the infrastructure and the company needs. I hope. If not, so wait. Think some more, and then do whatever you need to do, because, again, in the long run, you will be so thankful that you thought about everything in advance for scaling purposes, for anything that you really need. So I'm not sure if this is big enough. You tell me. But this is what I want you to take out of this presentation. So if you think about the code-based structure, it will allow you to set up Terraform as a platform and to have small state files, which is always a good thing. And set up any practices enforcement, because that way you help others help you, especially if you are the one to maintain Terraform as the platform. That way you just avoid any other issues, and people should just follow the standards that you put, and that's that. And that way people are onboarded to use Terraform and keep a high quality of code because of these practices enforcement. So like any other tool, don't use Terraform in an ad hoc mindset. Plan for your future needs. I want to quote something else from the article that I mentioned by Tisin Guo. He's a great article. You should check it out. You'll see a reference slide in a bit. So he said that programs evolve, right, and code changes. And it is really rare that things and code just stays the same, right? We have the term refactoring for a reason. Because if things would just stay the same, I wouldn't even be here talking to you about Terraform practices, because everyone would just use Terraform in the same way, and that's it. But it's not how projects work. And what is a project? From going from one desired state, from one current state to the desired state. This is a project. So in order to allow projects to get introduced to your environment and to help your company succeed, you should really plan ahead and think things through, and really use whatever you can in order to utilize Terraform in the best way possible. Even if you're a startup, that still think about scale. If you're an enterprise, think whatever you need to do. And these are the references, some references that I mentioned: the Terraform docs, labeling, tagging, and the post that I mentioned. And also Superlinter is also something that you can use for practice enforcement. That it's like a bundle of GitHub actions that you can just apply, and out of the box you have a great set of checks. That's it. Thank you so much for listening. Woo.